Microsurvey StarNet allows you to perform one-dimensional leveling, two-dimensional, or 3D least squares adjustment. Let's have a look at a few of the workflows. The first step in almost every StarNet project is to run a converter. So with a leveling project, you'll be importing data from an electronic level, and you can use a variety of converters that are already built in or online. Or if you have old manually recorded data, you can record it into a text file. Typically next you want to run the loop check tool to check all the individual closures in your network to see if there's anything that miscloses. There's also a special tool that allows you to test each of these closures against, for example, some NGS standards to see if each individual loop meets standards. When you adjust, you can review the results, and you can use the listing to identify outliers and satisfy yourself that the results have met expectations. With 2D data, the first step is still to import data, and you're usually going to use a converter. Many of these are available from StarNet or from Microsurvey, and many third-party companies also allow for export to StarNet. Once you've imported the data into a 2D project, you can assign the adjustment type as 2D. If you need to combine GPS data with 2D conventional data, you've got an option to assign an average project elevation in case elevation scale factors need to be computed. You'll also notice that in the input files you've got the option of using inline options to substitute stretches of 3D data along with 2D data, and in the end you'll still get a 2D adjustment. When you run the adjustment, the chi-square test is the first place that you'll always look to make sure that you've got good goodness of fit and that your chi-square test passes. And when you're finished, you're going to review the results in a listing, and you can identify outliers which you may need to edit and then run the adjustment again. 3D workflow is similar. You're going to import GPS or conventional data and leveling data as well, in fact. And you're either going to use a converter or an export routine. You're going to assign the project as 3D and a coordinate system and geoid modeling if you need to. You're going to typically manually edit your input files to make sure that your network is constrained appropriately to either desired points and elevations or a mixture of both. You've got the option of assigning geoid modeling over in the modeling section of the project options. You can also assign a vertical deflection file, or you can input the eta and Cassi values directly in the deflection section. You'll also notice in the bottom left that you've got an option of constraining your project either to a CH record, which is ellipsoid, or a C record for an orthometric elevation. When you're finished running the adjustment, you can output the results as a text file, as a DXF file, as a KML file. And the extensive listing can be used to print out a report and establish that all of the required geodetic attributes and statistics have met your requirements.